The results that we have obtained for constant acceleration case in one dimension would work for the vertical direction also, as long as it is just one line, whether it is in horizontal plane or it is vertical, there is no problem. You know that something, if you drop, automatically falls towards the ground. So we say Earth attracts. And there is an acceleration associated with this attraction. That acceleration falls as you go away from the surface of the Earth. But near the surface of the Earth, this acceleration is more or less same. Though there are some variations, but for our purpose, we can normally neglect those variations. The value of this acceleration is around 9.8 meter per second square, and it is pointed downwards towards the center of the Earth. Even if somebody kicks football and it goes up to certain height, this value of 9.8 is same. But if it is about large distance upwards, large in comparison to what? Comparable or part of some radius of the Earth. Part of the radius means, say, half times the radius of the Earth somebody goes up. Half times the radius of the Earth. So 6,400 kilometers is the radius of the Earth. Half of that, 3,200 kilometers. If somebody goes up 3,000 kilometers high, then one should not be using 9.8. Even for 1,000 kilometers up, one should not be using 9.8. But for football or for cricket ball, for example, these heights are not in kilometers. They are in meters. So 9.8 is very much workable, and that's what we do for common problems. We apply those three equations for vertical direction. Sometimes it is convenient to take upward direction as positive. Sometimes it is convenient to take downward direction as positive. Accordingly, acceleration will be positive or negative. Now, G, which is 9.8, is always downwards. So if you have taken upward direction as positive y that is, and G is always downwards, so if you have taken upward direction as positive, then you will take A equal to, acceleration equal to minus G. Say you are applying V equal to U plus AT equation, V equal to U plus AT equation for Y direction. That means Vy equal to Uy plus Ay into T, where Y is the subscript. V equal to U plus AT, Vy equal to Uy plus Ayt. So this Ay, if up is plus Y direction, this Ay will be minus G. But sometimes it is convenient to take downward direction as positive. If downward direction is positive, then A will be plus G. And note that in these three formulae, X or S, whatever you call it, is the position with respect to the observer. It is a position with respect to the origin or observer. So when you have such cases that a particle ball goes up and it falls back, goes up, falls back. Then while going up, it crosses some point, and then when it falls, it crosses the same point. With respect to your origin, that point comes two times in the journey, up also, down also. The equations that we use, in them, X is position or S is position. So you can use the equation for that position also when the ball is going up, and for that position also when the ball is falling. That may sound somewhat miraculous, but that's exactly how it is. So if I ask you this question, that a ball is thrown up and it comes back, there is some point in the journey at which time does it cross that point. Ball goes up to certain height, there is some point in the journey. That point, at what time does it cross? Then your answer should not be one answer, but it should be two answers. And automatically they will come. Because when you will use those three equations, or one of those three equations, you will just use y equal to something. That's it. And you will automatically see that in time, it will become a quadratic equation. Y has only one value. Whether going up or going down, y doesn't change. You're not applying the formula differently for upward motion, for downward motion. Sometimes students do that. That upward motion handling separately, downward motion handling separately. That's an elementary way of doing things. Right now, when you understand that S is the position or X is the position, you can just take one direction positive. Say you take upward direction as positive. Even downward motion can be handled that way. Because it is about position, not whether going up or down. So whether it is upward motion or downward motion, if you choose some particular position, when does the ball cross that position? Then automatically you will find a quadratic equation in time. and it will have two solutions, and both will be possible solutions. So that's one thing very important to understand, that you are talking about position. Sometimes position becomes distance, sometimes it becomes displacement. So you will hear all those words, that distance traveled will be so much, displacement is so much. But technically speaking, in those formulae, it is the position which is used. Then, another important point is that direction of acceleration has nothing necessarily to do with the direction of velocity. Direction of acceleration doesn't necessarily have to do with direction of velocity. It is possible that somebody is going up, but acceleration is downwards. It is also possible that somebody is going down and acceleration is also down. And you can understand it very well in the context of small g. No matter whether your ball goes up or comes down, g is always going to be downwards, 9.8, if it is near the surface of the earth. Then, if an object is dropped from some moving object, if an object is dropped from a moving object, then u, initial velocity, may not be zero. Even if it is just dropped, no effort is made to throw it, just released. Even then u may not be zero. This is a common problem that students have in understanding. Suppose you are traveling in a train, let's say. You're traveling in a train. Now, train is moving and you drop something out of the window. As far as you are concerned, what you are holding, what was at rest. What you are holding was at rest. Isn't it? Train is moving, but for you, that thing is not moving. It doesn't fall. You can just comfortably hold it. Actually, you are also not moving with respect to what you see. You don't find yourself moving. But then somebody who is watching you from outside, for that person you are moving. When you drop something from the train, then that thing was in contact with you. So that thing was moving. Normally if you drop something, it will fall vertically. But if you drop something from the train, it will not fall vertically if the train is moving. Because when you drop that thing, it has the velocity of the train with it. Suppose train is going in that direction and you drop a cup of coffee. If you drop it just like the way I'm standing and I'm dropping, if I drop, it will fall vertically down. But now the train is going in this side and the cup of coffee is also going in that side. and then you drop it. So when it leaves your hand, it has that velocity with it right in the very beginning. Right in the very beginning. When it was in contact, only then. But nobody loses velocity instantly. It doesn't stop in air. It will actually continue to move with same velocity. And then gravity will make it fall. So it won't fall like vertical, but it will travel forward and then fall. If you drop anything which is already having some velocity, then it doesn't fall vertically down. So the rule is that any object which is in motion carries with it the initial velocity of its motion, even when it detaches itself with that motion. Any object which is in motion carries with it the initial velocity of that motion, even after it detaches itself with that motion. That always happens. So if an aircraft is moving and it has to drop missile here, just drop it. It has to just drop the missile here. So if the pilot, when it's just above this point, drops it. Drops it. No, not throwing, dropping. Just drops it. It will never be going to fall vertically, because if the plane is moving in this direction, then the missile will carry that velocity of the plane. Even when it detaches itself from the plane, it will carry that velocity. So it won't drop like that, but it will carry that velocity, and then gravity will make it fall. So it will fall ahead of that point. So if that person has to drop missile here, he should somehow manage to make the plane still and then drop it. Just like when I make my hand still and then I drop it, then the cup of coffee goes straight down. But when my hand is moving like that and then I drop the cup of coffee, it won't fall here. It will fall somewhere in the forward position. So an object always carries with it the earlier velocity it had when it was in motion, even after detaching itself from that motion. So if you are going up and you detach yourself, you will still have that upward velocity till gravity makes you stop and then lets you fall down. That's an easy one. Can you solve it?
So it would be 30 meters, 35 meters.
Let me see. $35. If there are any questions, then let me know. Also an easy one, try this. Acceleration will be negative here.
So 12 meters.
Let me see. $12 meters. Any questions? Let me know.
So do we use v square is equal to u square plus 2as for this question?
V square 0. Yes. V square minus u square equal to 2s. That's what you have to use. So any problem in that? Acceleration you have to take negative, minus 6. This is a simple one also. So first you should try.
So 21.75 meters.
That should be fine. The answer I have is 22 meters. Now, let me know if you have any questions. there are no questions, then I will move on.
So he gets caught 100 meters from the turning.
I will check that in a moment. Suppose that is the distance traveled by the bike in time t, then the same distance will be traveled by the police jeep in how much time?
So he'll get caught after 4 seconds.
My question is, if this distance after turning is covered by the bike in time t, then the jeep will also have to cover the same distance. In how much time will the jeep cover that much distance?
So t plus 10 seconds.
If somebody is traveling at 90 kmph, will that fellow take more time to cover the same distance? T plus 10. Shouldn't it be less time? From these two equations, can you find out x? And I have checked the answer meanwhile. It is 1 kilometer. See if you are getting x as 1 kilometer. You just have to get rid of t. Find t from the first left equation and put it in that right one. Any questions? Let me know. Let's take upward direction as positive direction. Plus y you can say. S equal to ut plus half at square. But time is not known.
So distance is 125 meters.
Let me check. If upward direction is positive, then ay is minus g. Can you solve for y now, which will be h? $40 meters. Any questions? Let me know. The time to reach. Can you find out time?
Sir, could you please confirm whether this would be 40 meters only?
I have given you the answer that I have. It is 40 meters.
So the equation comes out to be minus 20 s is equal to minus 2500.
You mean one side is negative, other side is positive?
Sir, they would cancel out. That is okay, sir. The problem is of the value.
Okay. You mean calculation? I think there is some problem. With part A answer. This would need correction. See if we are getting these two now. Can you find out C, speed at half the maximum height?
It would be 25 meters per second.
25 meter per second. You said 25 or 35?
So 25.
The answer I have is 35. See if you're getting 35. Any problem, let me know.
Sir, I'm getting it as approximately equal to 35.
Fine.
That is around 35.3.
That's no problem. So that's the equation. Any questions, let me know. This is your assignment question. We stop now.